Hello, hello. We should
Hello.
be live. There are three of us today. Hello, everyone. Good evening, good morning. I don't know how many of you are from Poland, how many from other countries. Welcome everyone on our next TWF meetup powered by Avanet. And today there is a pretty nice new topic about everything you don't know about Git. And before we start, let's focus on some things that we are always focusing on at the beginning. So, of course, you're free and welcome to go to our website, TWF Community, to see for sure a list of our previous meetings and to get opportunity to just become a speaker because you can fill up the survey and then uh, show yourself here on another meeting next month or maybe some other months. Besides that, of course, we have our YouTube channel. You can see all of the recordings there. So if you missed something, just go there and watch the recording. Um, yeah, that's it from our side. So from the organization part, and I'm really, really glad that we made it today. And guys, thank you very much that you joined and you want to share some knowledge about Git. I already, spoiler alert. I already saw this presentation, or at least part of this presentation, and I find it very interesting. So, if you are working with Git on daily basis, this presentation is really important and really interesting. It's not some things that everyone knows. So really cannot wait to you to present this to our audience.
Thank you, Veronica. And thank you, Magdalena, as well, for inviting me. I'm very happy to be here. It's a lot of fun to do a meetup like that for the other side of Europe. I'm based in Spain. So thank you very much.
Okay, let
And
me
I'm ready to
share
start when you
your.
want. Yeah.
Yes,
All right.
your screen is visible, and now it's time for you, and we are just muting ourselves.
Good
Good
luck.
luck.
Thank you. All right. Hello, everyone. I anticipate that this is going to be about 40 minutes, I think. Any questions that you have, put them in the comments, and I hope we can take them at the end. Let's see how long this takes us. So, this is everything you don't need to know about Git because it's more like bits of trivia, facts, explanations on how Git is built, but it's not going to help you be an actual better programmer. So don't. I hope this is not what you're expecting because this is not what I'm going to bring you. Towards the end, I will have just a couple of actual commands that are useful, but that's really the smallest part of the talk. Having said that, I want to start by telling you why I'm giving this talk, why I built it in the first place. Some years ago, I was working at a startup that was hiring tons of really junior developers, and that was really cool because I mean they were learning and they were super eager to learn, but I kept seeing them getting so confused about what I considered basics of Git. But as soon as I told them something that was a bit out of the ordinary, they were confused. Like, hey, check out this specific file I was telling them, or give a name to your stash. Suddenly, that was out of the rails, the guidelines that they had learned, and they didn't know what to do. So I got a bit frustrated out of all those juniors who knew how to do one thing very specifically, but did not know everything around the tools they were using. And this is how this talk was born. It's like an explanation of, like I was telling you, a little bit the data structure, also a little bit of how Git was built to make you understand, hopefully, why it works the way it works and what you can do with it. So if you think about this like a hiking map, I'm not going to tell you about exactly which path you have to take to get anywhere, but I'm only going to tell you what are height lines and why is this path in red and this one in yellow, and then just let you figure out for yourself what that actually means. And last thing from introduction before I actually start with Git, this is me. I'm Garance. I think you won't be able to pronounce my name. It's fine. It's French. It's really impossible to pronounce. I've made my peace with it. I'm fine with pretty much everything. I work at a startup that is called Factorial. We do a software, well, it's a SaaS for managing companies all in one, like HR, finance, everything. And I'm based in Barcelona in Spain. It's an amazing city. If you've never been, I really recommend it. I mean, it has everything. We have the sea, we have mountains not too far, great monuments, great food, great wine. I really recommend it. And finally, you can find me on Mastodon. I mean, I have Twitter as well, but I don't really want to promote it anymore. So find me on Mastodon. And that's it. Oh, last thing I forgot to say, I guess, is my job title. I'm an engineering director. I'm an engineer, but now I've moved on the management side of things. It's a lot of fun. If you're wondering about that, also hit me up. I'm glad to talk about it anytime. Now, let's get started. Of course, you know about Git. I mean, if you're here, you know what it is, and you even probably use it. I'm going to give you a couple of facts about it. Nothing really revolutionary, it just all comes from Wikipedia. It's a version control system, but it's really not unique. It's actually one of 41 version control systems referenced by Wikipedia. So that's only the notable ones. Imagine how many more actually exist. So we have to try to define it a bit with a bit more bounded. One thing that we could say is that it's a distributed version control system. But even then, out of all the distributed VCSs, it's just one out of 15. So there are many, many. So then that leaves us with the question, at least in my opinion, of but why are we talking about Git and not about anything else? Well, I don't have like real absolute numbers of usage because we don't all have trackers on our computers recording all our actions, or like we probably do, but that's not what they record. That's not interesting. So, what I do have is StackOverflow developer survey results, which I think brings us pretty close to the real picture. I have 3 years of data. And when I mean 3 years of data, I have like for 3 years, they asked specifically the question, which version control system do you use? And here are all the different options that people have been selecting over the years. And the first year of data that I have is 2015. Yes, 2015. And so, as you can see, Git was like, I don't know, about 60% or so, 68. And then there was a bunch of people using Subversion, Team Foundation. A good share said, oh no, I don't use version control. I don't know how they're working. I mean, probably not in a team or not in a company in a team. I don't know how they do it, but well, fine. And then a little bit of Mercurial and CVS. Okay, the year after that, well, 2 years after that, actually, they asked again, and those were the results. A fun thing about it is Git was like at the same proportion of people saying they use it, but everything else had dropped. What happened is that there were many other options that were selected, like zip file backups or copying and pasting files to network shares. I'm not so sure I would call that using version control system, but apparently yes. I guess if it works for them, it's fine, right? It's like I wouldn't want to work this way, but why not? And then the last year of data that I have to answer this specific question, which VCS do you use? Those were the results. Pretty insane if you ask me. Git went pretty much to 90% of usage. And then, I mean, you still had a bit of everything else, but it's really smashed by the usage of Git. So, this is why this is about Git and not about Subversion or Team Foundation. Git is where it's at. Git is what everyone uses. To give you an idea of how much Git is what everyone uses, Google, before they switched to Git, they were using Perforce, and it's not even on here anymore. Like, one of the biggest tech companies was using a tool that has now completely disappeared. And talking about completely disappeared, another way to look at Git's popularity is Google trend results. So on this chart, it's worldwide Google trend results for the top systems that were just in the previous chart, right? And you can see that about 2009 is when something happened and Git just took over. I'll be honest, this is about when I graduated high school, so I've never seen a world without Git. For me, this is the standard. Um, I recommend you, though, to not get too comfortable if you're like me and you don't know another system, because we're in tech. I'm sure that soon enough, something else will come and take over, and we'll just have to learn it or be the old dinosaurs who say, no, 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 I'm staying with my system. The way we still have this like 6% of people on SVN. I would rather not be a dinosaur, so let's adapt, right? So much for Git's popularity. Now I want to tell you a bit more about the historical context of Git and rewind to how it was actually created. So you might know that or not. It was created by a Linux creator, Linus Torvalds, and it was created for the purpose of the Linux kernel source code management. So it's very tied to this community. And the way it happened is pretty funny. It's a very Linus Torvalds story, actually. So the Linux kernel people, they were using another version control system at the time, which was called BitKeeper. And it was a commercial system, but they got a free license because, well, I mean, it's Linux, it's a good cause, let's say, so they got that. But, well, that group got into a fight with the owner of BitKeeper, and they had to stop using it or start paying. So, well, Linus Torvalds' answer, obviously, was not to start paying, was to say, okay, then, I'll just create my own thing. And that's what he did. That was in 2005. So, like 13 years ago now. No, 18 years ago. It's starting to be a lot. Hopefully, everyone who's listening was already born, but I guess I'm having less and less of a chance of that as I keep giving this talk. Something really interesting about how Linus Torvalds created Git is one of the guiding principles he had was about performance. And that quote really stuck with me, and I want to share it with you. He said, Git, to some degree, was designed on the principle that everything you ever do on a daily basis should take less than a second. Honestly, if everything that we developed as developer was made with this principle in mind, I think life would be so much better, so much more relaxing. I really invite you to think about that the next time you code something and you're like, meh, it works. Think, does it work? Is it fast enough? Is there someone somewhere who's going to get mad because it's too slow? If yes, try to improve it. The world would be so much nicer. Anyway, that's me. Another thing I want to tell you about Git, now that you know why it started to exist, its name. Um, I mean, probably most of you are not native English speakers because this is a Polish meetup, right? And you might have never thought about looking it up. What does Git mean? Does it even mean something? Well, it does. And it's a bit crazy. This is the dictionary definition of Git. A Git is an unpleasant, silly, incompetent, annoying, senile, elderly, or childish person. How weird is that, right? So, this is a tool that you use every day, and that word is actually an insult. What's even crazier is that this was done on purpose. When Torvalds was asked about why he called Git, he said, well, I'm a bastard, and I name all my projects after myself. So that's it. First Linux, now Git. I'm a rotten person. So this is weird, but yeah, this is what Git means. Luckily, though, because nowadays Git is really not just him, even though he created it, you can retrofit it in a really cool acronym and say that Git stands for Global Information Tracker. So everything is safe. You can tell your parents that you work on Git without having to say that you work on the project of a rotten person. Last piece of trivia, I think, that I have for you today is that Git's source code, well, it's on Git. They use Git to develop it. And very conveniently, there is a mirror on GitHub. So you can just go there. It's like github.com, git, and you can read all of the implementation. If you know how to read C, you can see everything and see who is doing what. It's pretty cool, actually. They don't use GitHub directly, let's be clear, but there's a mirror, so everything is always there up to date. And that leads you to realize that Git is just another piece of software with versions and updates, just like the one that you and me write every day. So right now we are at v39 dot something for the patch version. I don't remember. And they release super often. It's pretty interesting. Like the V239, the minor version I just mentioned, it became a release candidate end of November, and it became the official version just 3 weeks later. So it goes pretty fast for something that is so much used. It's pretty cool. Major versions don't happen that often, obviously. Like V2 was released 9 years ago now, but still, it happens. And like any piece of software, like I said, it's just like the one that we write, it contains bugs. And so when something really weird happens on Git, it might not be your fault. I mean, let's be clear. It's most likely your fault because you don't know what you're doing, but it's not always the case. So to illustrate that, I picked a handful of bug fix comment messages that I found in the project just to show you what's going on there. Here's one, super simple. Fix use of non-existent function. I mean, how did that pass the build and the linting and everything, right? In my projects at work, I know that that would never happen because we have so many checks in place, and yet it happens in a project of this scale. I find it crazy. Here's one that really takes the cake. A recent update to git stash pop made the command empty the index when ran with a specific option. So this is what I meant by it's not always your fault. There was a bug that made that when you just emptied your stash, it was removing everything you had in your index. How crazy is that? Well, it was corrected, so it's all fine. And finally, just for the pleasure, localization, fixed typo in the README. Um, Everyone makes mistakes, from the smallest to the biggest mistakes, even in this kind of huge project. I'm adding this as a call to participate in open source software. I mean, there is space for everyone. You don't have to be a genius to participate in any given project. They need everyone's brain power. So go ahead, have a look, and contribute. All right. Now it's time for the serious parts. I gave you some history and fun facts. And now I want to talk about Git's architecture. I want to tell you about the data structure, how what it relies on, and I hope that you will find it as fascinating as I do. Before we start, a small disclaimer. I did study engineering. Even had classes on cryptography, on data structure, but that was like a while ago. I don't practice those every day, so we are way out of my comfort zone. So if you're an expert, you might think that my explanations are too simple. Bear with me. Otherwise, I hope you understand them. This is very much an instance of learning in public, and I hope to just give you the tinge of curiosity so that you go and explore more if you're interested. So Git's underlying structure, it's a tree. It's really very simple. It's just a tree, or many, many trees, actually. Of course, it's not any kind of tree with any random property. It's pretty specific. Everything is a Merkle tree. So, for anyone who doesn't know by heart what does that mean, we'll get back to the basics and I'll tell you that. Merkle, by the way, doesn't mean anything. It's the name of the scientist who defined this data structure. It was an American. Well, he is actually, he's not dead, an American. So there are two things that you need to know about Merkle trees. And I really mean it. There are only two things you need to know about them, and then you got it covered, you know everything. The first one is that in a Merkle tree, every leaf, so at the bottom of the tree, right, is labeled with a cryptographic hash of its data. So, like, well, you have data anywhere, and every leaf contains data and has a label that is a hash of that data. And the second thing you need to know about those trees is that every non leaf, so every node higher up in the tree, is labeled with a hash of all of its children's labels. So that's the two things you need to know about Merkle trees. First, you have leaves, of course, at the bottom of the tree, and they have a label that is a hash of the data. And then higher up in the tree, every node also has a label, and that label is a hash of all the children's labels. And that's really it. Once you know that, you know everything there is to know about Merkle trees and about Git. Obviously, now I'm going to give you examples because that might sound very abstract. So let's look. The data in Git, it's not files. Git doesn't really care about files. Git looks at blobs of data. Blobs, by the way, it's a real word. Real word. It means binary large objects, but it's not very important. Just think of a blob. I mean, I think it sounds really good actually. Think of blobs as just binary data coupled together. It doesn't really matter if it's a single file, multiple files, just a few lines. Completely irrelevant. So here in my examples, I have two blobs of data. And if I want them to be leaves, I just need to give them a label. And that label will be a hash of the content. So this is where the trees start. In practice, each one of those blob is a leaf on a tree. So this is what counts for Git, remember, not the actual content, the label. It's the only thing that Git will keep in memory. And this is what, having this label, becoming a leaf, is what will make our blob more than just random bits of information. It gives it really an identity. And you can find that label even without committing in Git. You can just calculate the hash, and you do that with a hash object command. So you can just do git hash object and with any blob of data, and it gives you the label. So this is what it looks like, and I can redo that with the owl, and here it is, git hash object owl, and here's my blob of data. Now, that's one piece of the tree, leaves. Where is the rest? Where are the branches? That's where commits actually come in. So let's look at my two blobs again. I just moved them around to have space. If you bring them together, here's a tree now because they have a parent, right? And so that parent, that label, that yellow label, is just a hash of those two other labels together. Now, to get an actual commit, I need to add another one. This is where it's pretty interesting, and I guess you have to make sure you don't miss that part. So the labels that are in yellow, they are just they represent the content only, right? I have the 4A 0 blah blah that represents my Robin blob, and then E3 blah blah that represents my owl blob. 2BC is a hash of those two things, but in a commit, you have a lot more information than just the content. You know who has committed and when, and there's a commit message, etc. So that is in this blue label, my A0BA. And this brings a pretty cool property of Git, which is if you had the exact same blobs on your own computer and you made the same thing as me, the same commit, we would have all our yellow labels being the same because the contents are the same, like the file names, etc., are irrelevant. But we would just have that blue label, the commit hash, being different because this is where there is the metadata actually. All the information about the author, the time, is the only thing that would change. And you can check on that by yourself if you want to like reproduce it and see it happen with those commands. So you add your different blobs, you commit them, that's fine. And then how do you find back all those hashes? Well, if you do a git log, you can see the commit hash. This is the part that you're used to see, right? And that you always see when you log because you're spelunking for the history of a project or something. And so here I have the commit hash and all the metadata, the author, the date, the message, and all of that. But so let's dig a bit deeper because that's what's interesting today. And let's look at, let's ask Git, okay, what is actually in that commit? So we can ask Git cat file and passing it our commit. And it tells us, well, this commit contains a tree, plus all the metadata information that we already know by now. So, okay, Git tells us this commit contains a tree. Now let's ask Git, okay, what is in that tree? So for this, the command we can use is git ls tree and pass it the hash of the tree head, let's say. And here we are back with our two blobs, the owl and the robin, and they have the same hashes. So, like I was telling you, it's pretty cool because we would have, if we both did that on our computers, we would have a different commit hash, okay? But then everything inside the commit, well, the tree inside the commit at least, would be the same. And now I hope you're still following because I'm going to add a bit of complexity. I want to add a second commit because after all, the whole point is to have a history, right, in Git. We're not just doing one commit and leaving it there and creating a new repository. So if we're introducing changes, let's say just adding some changes to the owl, all right, I make whatever changes on it, I add it, and I commit it. So far, it's easy. So what you already know that you see when you do changes is that creates a new commit, and that commit has a new hash, all right? And then what does that commit contain? Well, I have my little owl that is different. Okay, so a new label there. Since the owl has a new label, it means that the tree contained in my commit is different, obviously. And but my commit, the tree inside my commit, doesn't contain just my new owl. It also contains a reference to my original robin. And this is pretty cool, actually, because it never Git is not repeating anything over. It's just pointing again, referencing again the exact same thing that was before, if it hasn't changed. And you can actually, you don't have to take my word for it. We're going to look at it same through Git commands to see the hashes and who contains what. So first, git log. That's the same as ever. You know it. So now I see that in my repository, I have two commits. We've seen them, the A0BA and the 98.2. Cool. Now let's ask Git, okay, and what does this new commit contain? And same as earlier, it tells me, well, this commit contains a tree, and here's all the metadata. There's a parent additionally. We don't care about that right now. But so, okay, it tells us this is the tree that this commit contains, right? This 74B, whatever. Let's see now if we ask Git what is contained in this tree. Well, you can see that it contains our new owl, the one that we just created, and the previous robin. At the risk of repeating myself, I find it really cool that it's just referencing what already existed without us having told Git, hey, and by the way, keep all the history that existed before. And this leads to an amazing property of Git, at least in my opinion. I find that powerful and amazing, which is that it's impossible to change history. It's pretty controversial. Let me explain what I mean by that. If I try to go back in time and to say, okay, in fact, I want to change this robin, but like not just now after I have made my change to the owl, I want to change the robin. If I decided I want to go back and the robin is not the same anymore, going back in the past, force pushing. So like, sure, I guess you can do it, except if you change the content of that robin, it means that label is going to change. And if you change that label, since it's just a leaf on a tree, it's going to have a huge impact. It will change that one, of course, and then that tree head as well, and then that comet as well. So you can't do it in the sense that you're rewriting the entire history if you do that. You can't just go back in the past, make a little change, no one sees it, it's fine. That's why I'll repeat it, changing history is impossible. Again, sure, you can like force push your stuff and it's going to work, but you will be rewriting the entire history, not doing a one little change. And that would work if you were on your own, just doing your little side projects, or not even that, but just not caring about keeping the history and what has happened when. Okay. But contrary to that sparrow, programming is usually not solitary, and contrary to the cliche, right? In reality, I don't know about you, but at work, for me, this is more what reality looks like. Programming in a distributed system such as Git is more like this. Nothing is linear. Everyone has the project all the time on their computer with the entire history. And if you go and you change one thing somewhere, it's going to impact many, many people. And even if it's not 100 people because you have a small project, it's still going to impact them and screw with everyone's project. So, not great. Okay, another thing that I want to tell you is to dig a bit deeper about how is this possible? Where is all of that? And well, the answer might be obvious, you probably know it, is that everything is stored in your .git folder. So, but when I say everything is stored, I really, really mean everything is stored in this .git folder. Luckily, everything is super neatly organized. Like everything is there, but it's really, really well organized. Because remember, Git doesn't care about the actual files and doesn't store them in all their many versions. It's only storing hashes of those contents and the shape that the trees have. That's all that Git cares about. It allows to compress everything to really not much. And if a piece of code is in your repository for the past 3 years but hasn't changed, it's never been duplicated. It's just always the same piece, the same hash that is referenced every time there's a new commit. So it's really efficient. Of course, the other side of that coin, which I mean can be good, can be bad, depending, is that a piece of code that was deleted, no matter how long ago, is still going to be in the .git. So nothing is lost. Again, can be good, can be bad, depending on what you were trying to delete. I invite you, I find it interesting to check on your work projects and compare the total size of the repository against the size of the .git folder itself. For us at work, last time I checked, the backend was like 500 megabytes. So that's like 6 years worth of brain and sweat and tears. But the .git itself was 300 megabytes. So like more than half of the whole project is actually its history. Imagine. All right, I want to show you a bit what is contained in this folder in practice to make it less scary and show you how you can actually find things in it. So an interesting thing is the logs folder. One way, remember how I said Git was built with performance in mind? One way we achieve that is that all the logs, so the shape of all the trees, is just written. It's very simple. There is in the logs folder, there is one file per reference, I guess, because it's not just per branch. Because in my example, it's head, and head is not a branch, right? But so yeah, there's one file per tip on Git, and so whenever you ask Git for a log, that's where it's getting it from. It's never recalculating everything from scratch. So it's really simple to to get really really fast the entire history. And in this example, well, you can see my two commits. You see the one that starts with 5 zeros. That's because it's the very first one. It has no parent. And then the other one has it. And so the first hash is its parent, and the next hash is its own label. Another interesting folder in this .git folder is the objects one. It looks pretty scary at first. It's just this folder that contains folders with random names, but this is where all the hashes are actually stored. And I want to show you one in particular just to show you what it looks like. So for example, if I go in this to be folder, just have another hash in it. Okay, I can just ask Git to tell me what the hell is this hash. I do that with the cat file command. If I give the T option to it, and I just pass it the whole hash, see, with the folder name and then the hash itself, it tells me, well, this is representing a tree. Okay, now let's ask Git, but what is that tree? If you remember it, uh, we had this tree earlier that had that label, this 2BC. And I can check it by asking Git with a cat file again, but with the P option this time. Okay, what does this tree contain? And it tells me, well, that tree in this case contains two blobs. So we're right back at the beginning. And well, I hope that helps demystify a little bit this folder and how you can learn from it. And well, to finish off on Git Data Structure, I want to leave you with a thought. If a Git repository is always self-contained and it's impossible to change its path without your peers knowing about it, does that bring you anything to mind? Well, at least to me, uh, it's just most similar to the blockchain. Or rather, the blockchain is very similar to Git with just a handful of extra features. It's really, I mean, everything is a tree all the way down. It's a slightly different one, but it's the same. I find that really funny, honestly, because the blockchain is so hyped up and you can do so many things on it, so secure and impossible to tamper with, etc. And then it's actually so similar to this tool that we use every day without thinking about it and barely knowing how it works. Um, so yeah, let's just look at our tools from up close, I guess. All right, so I'm almost finished. I hope you're still following. I have no clue if there are comments or anything. Now, to finish off, I want to mention a few commands because I've been telling you this is the talk of everything you don't need to know about Git. But come on, I also want to leave you with a couple of useful things. So hopefully you're still here, and let's see how to make your life a little bit easier. The first topic I want to touch is how to get back data. You know how I mentioned that I built this talk thinking about junior developers who did not know how to use Git beyond the basics, guided things that they knew? Well, a very common topic was spending hours and hours retrieving data that they had lost for unknown reasons. And there are actually a couple of commands that can help in those situations. The first one is Git Reflog. If you already know about it, great. Close your ears for a second. Otherwise, let me tell you, it's for small mishaps. Git Reflog, it's a parallel history of your repository, where Git keeps all the commits, like a normal log, but also all the actions that happened around it. So, like, it keeps any checkout, any reset, any amend. It's really logging all the references of everything that has happened in your repository, not just the normal log. So that's an example that we had. Don't remember where, from work or something. Anyway, as you can see, okay, it has the commits, but it also has checkouts, resets, uh, changing branches. It really has a lot more things. And if you've told Git about a file or the state of something at some point, you will find it there. But of course, I'm saying it's for small mishaps because you must have told Git about it and you must have committed it one way or another to see it. But you can undo resets, checkouts, so pretty handy. Now, in case of a bigger problem, Git has you covered with FSCA. So Git FSCA, I don't really know how to pronounce it, but I found this way very funny, is to store all of the orphan data. So hopefully it helps you recover from everything else. It has a couple of options. So if you use the unreachable option, git scat unreachable, you will see only objects that are not reachable from the outside. So like they're not associated from a branch or a tag that is pushed to the repository, but they still might be reachable somewhere else, like a local branch of yours, another commit that you have made, this sort of thing. See, I have trees, blobs, commits. It contains all sorts of things. And then you can use the other commands that we were looking at earlier to see what does those hashes contain, what does that tree contain, etc. Another option of git-scat, if you're pretty desperate, is dangling. So dangling data is not referenced from anywhere anymore at all. So there's no branch pointing to it, no commit pointing to it, nothing, whether it's on your computer or in remote. But they're just things that Git hasn't gotten rid of yet. So say you've made a commit, but not linked to anything, or linked to something, but you've since deleted that branch, deleted everything. There's a chance that it still exists for Git in this dangling state until the next garbage control, of course. Well, it's not called garbage control, I think, in Git, but you get the idea. And you can take out the big guns with Git scat full to really see everything that is pretty lost, but same spirit. And a really helpful option of Git scat is this LostFound. Because of course, seeing that list of hashes is not so helpful, right? I mean, you're a bit desperate. You just see those random hashes. What are you going to do with them? So LostFound is going to write everything that it finds, so like the whole output, inside a new folder, Git LostFound. And this way, you can just easily go through that folder and see what it contains without like having to copy paste the output of the command and risk forgetting something, etc. So here, for example, it's written all of that. And then if I check, okay, tell me what is this hash? I can see that it's actually a file and it gives me the whole content of the file. So nothing is left, nothing is lost. And it works with everything. So like that example is with a file, but it works with commits too, right? And for example, a commit that would end up here is a commit that got squashed. If you rebased and you squashed commits together, you would still find them there. Okay, actually, I had a slide for that. So here's an example. That's a commit that was probably squashed and still exists, even if you can't find it in the folder anymore, in the repository. All right, I think this is the last bit that I want to share with you is about how to solve conflicts more easily. That's another very typical problem that I see so much at work from junior developers. Whenever there's a conflict, it's the end of the world. And actually, I remember that from being a student. It was more of a race of who commits first so that I don't have to deal with conflicts. Well, yeah, there are a couple of commands for that. The first one is Git Rara, or as a French person, I could say Rara. Sounds very funny, I have to say. Anyway, it stands for Reuse Recorded Resolution. So this one is your best friend if you're using rebasing and you're not pushing to main every evening. Because I mean, okay, better to use chunk-based development and always push to main all the time, but doesn't always happen. Gotta be honest, our features take us longer than 1 day to develop. And then if you keep rebasing on your branch from main, you will probably end up having a conflict. And if you keep rebasing, you'll just keep having to solve that conflict over and over again. That's a bit silly. So this is what it serves you. It allows you to solve the conflict only once, and then whenever it encounters that conflict again, it will just reuse the resolution that you've already recorded. Look at that. We're back on the rah rah rah. So it's not really a command, actually, it's a config that you have to enable. And you can just enable it globally. Honestly, I haven't come up with a reason not to. I'd be curious to hear why you wouldn't want your conflict resolution to be just reused. Of course, you still need an option in case you made a mistake solving your conflict. But apart from that, I think everyone should have that enabled by default, really. And okay, that's it. We made it to the end. From there, it's up to you. I hope you were intrigued by all this and you want to learn more about it. I have two resources to share with you. The first one is a short online book, Git from the Bottom Up. It explains all the data structure like I've been telling you, but you can like follow along, run those commands on your computer as they explain it. So it's really interesting. And I don't know, if you're a practical learner, it's really helpful. And the last one is the Git documentation. It gets a bit of a bad rep for being hard to read, but if you know what you're looking for, it's really, really explained in depth, and I can't recommend it enough. And that's it for me. I hope that was interesting.
Okay. I needed to unmute myself. Okay, so we are waiting only for Magda to join us. But thank you very much. For sure, it was really interesting. I see even the comments in the chat. Let me show them. First one about this.
Oh,
Your
damn. It has a proper
favorite comment.
meaning. I'm very disappointed. I much
Yeah.
prefer ska.
Ska. Yeah, so there are several ways how it's pronounced. Struck, she's struck, and more probably yeah, I'm even pronouncing it not good, but mm, thank you for this comment. Yeah, that's really helpful information. And I really love this one. Probably you would love it too. Set up a reminder for enabling Rara tomorrow morning. Yes, yes.
Definitely do. Yes, yes, yes. Like I said, I don't see a reason not to. As long as you disable it the one day you make a mistake in your conflict resolution.
Um,
But I mean,
yeah, you asked if there is anyone who disabled that, and that was me. Yeah, I enabled that, and then I had really a big issue. That was, of course, one-time issue, and I totally agree with you that it should be recommended by default, but you need to have in mind that, okay, there is this feature and it's turned on. I turned it off because there was one scenario when something has changed and the conflict should be changed. Like the resolution of the conflict should not be the same as it was before. And that was really a tough situation because I already forgot that this rare was
that's
enabled,
the risk,
and I was
definitely.
looking, oh my God, when through all of the files, all of the conflicts, what is happening? Yeah.
Well, I'm sorry I made you live through that.
No, that was even before I met you. So that was in the ancient history. Yeah. but nevertheless, this is really a good feature for Git. Really recommended. Yep. Okay. Everyone, feel free to add some more comments in the chat. Questions. If you have any other comments, yeah, Magdalena, I see you. Any other comments regarding the Git, maybe what to do or what not to do? Go ahead. And Magdalena, over to you.
Gareth, I have one question. Could you show us your Git? Because not everyone should be or can be familiar with this solution. So, like me, for example, and I would like to see how to use it and how you can just put the information or your code or something. Can you show us?
My Git, what do you mean? Like my terminal?
Yeah.
Okay.
How
Um,
how can we use it in practical?
that's a big question.
Yeah, I
Um,
know.
do I
I
even
should.
have Git properly set up? Because now I work all on the cloud.
No.
No, I can show you. Actually, I do have my Git configuration. Let me see. Gotta
I
find.
can turn off your screen right now, but
It's
if you
okay. Let's see. Of course, no. You know what? I don't have my phone with me. I can't log in.
okay, okay,
So
I'm
I'm
sorry
not
that
sorry.
I
I'm
really
saved by
surprised.
the
surprised
gong.
you. I'm
I
sorry that I
I've no
surprised you
clue where
this
my phone is.
question, but it was curious, and that's why I'm just asking. But no
Hmm.
worries, I will check it
Okay.
the other way.
But yeah, on my GitHub, I'll share that with you later. I have a repository, and I think everyone should have that really with my git config saved. I mean, and that works for saving your git config, saving your terminal settings. That's just so much easier when you change jobs and you get a new computer and you have to redo everything from scratch. I mean,
Mm-hmm.
it's kind of fun to reset everything, but at the same time, when you know what you like, why bother?
Mm.
Okay.
Okay, we have one more question. Why resolving conflicts with merge is easier than when using rebase? Do you have any thoughts about that?
Um, well, I mean, I don't have like the answer because I'm definitely, like I've been saying, not like the most expert ever. But if you do a merge, you actually create a new commit. So Git can go much smarter, just well, merging the changes together. Whereas if you're rebasing, it's applying commits one by one, and then if you've been changing the same file, it can become, well, yeah, it's going to be messy because maybe the same lines were changed and at different times. And I understand merging is easier, and I agree, I really do. But your history looks just so much nicer when you rebase that I still think it's worth it, as long as you take your time and you figure out your conflicts properly. But
I
if
have
you
a
do an
question.
interactive rebase, actually, it ends up being the same.
Yeah.
You, then
Mm-hmm.
you can just go
Mm-hmm.
one by one, and you see everything happening.
Yeah, interactive rebase is really fun stuff. Like when you don't know what you are doing, it really helps you.
Gareth, can you tell us how long are you using this solution?
Um,
Whew.
how long? So,
Because your
like I was.
be-
Go
because
ahead.
your data was since, I don't know, 215. Did I notice? Okay, 200 and
Um,
no.
yeah, like I said, Git was created in what 2007. I said, and myself, I'd say that I started in what did I say? 2000 and yeah, 2015 more or less. 2019. Yeah, 2015 is when I think I started using Git. But then, I mean, I'm talking about junior developers in this talk. I didn't start using Git more seriously before the past 4 years or so. It also took me a while to stop getting afraid and actually go and figure out what is going on.
Okay,
uh,
it's a lot
lately,
of
I
time.
lately I got the question from the audience from one of my colleagues. Uh, Could you recommend any materials, any sources where to learn Git and in the fun way, like interactive way? And that was a tough question. Of course, I remember the link that you already put in the presentation, but maybe you know some others sources
You
of
know
learning
what?
Git?
I do, but could I find that link back? But yes, yes, there is this really, really cool interactive way to learn Git that I had a university teacher who gave us.
Hmm.
Let me try to look it up quickly.
Hmm. If
Um,
you couldn't find it, just find it and send it via email to us, and we will post a comment or something with the details. So no pressure right now.
yeah, I
But
got it.
yeah,
I'll
the
share it with you in
oh,
there.
awesome.
It's learngitbranching.js.org. I can, let's see if I
Okay.
can even share my screen real quick if you want.
You can share one more time. I will
Uh,
send this in the comment
find
of
it.
the
Yes.
in the chat.
Present. Allow. So it's
Hmm.
really fun, this one,
Yes.
because it's
Hmm.
presenting it like a video game. I mean, like old school video game, obviously, but with different levels. And you can just start with the very beginning. Well, I'll pass the tutorial, obviously.
It's
And it
great
tells
material.
you, okay, this
Yeah.
is your
Hmm.
objective. Like you want to reach a picture that looks like this, and then up to you. How do you get it? This is your starting
Hmm.
point, and you had to get to having a second branch. Like this is your goal, and then which comments, yeah, what do you type in your terminal to get there? And
Yeah,
while it's
that's great.
commits, it's really easy, and then it gets harder and harder, making you rebase and everything. So that's really, really cool. I remember doing that when I was at university. I recommend it.
Good game.
Thank you very much.
Okay.
Okay.
We will leave this link in our comments in our YouTube. Okay, Veronica? And
There's
then
already in
some
the YouTube channel, yeah,
great.
in the discussion, but probably after the meeting, we will provide any like the post about the meeting, and probably there would be the this link too, so it will
Yes.
be available to all of you.
Awesome.
Awesome. I really enjoyed this presentation, and thank you, Garens, for being in here with us. It's great to see the. I think the Veronica just said it, the first woman with us, and it was very nice and very I don't know, practical to see. Yeah, very thank you, and we hope that we will have more that kind of person in here, and that's why I'm just thanking you for this one and this first one.
Well,
Thanks,
thank you
Garens.
for the invitation. It was great to speak here. I recommend to anyone who feels like it to apply and to come speak.
Thank you
Thank you
very
very
much.
much. Okay, so I believe that's it. If there is anything that you want to learn about the Git, of course, reach out to Garance or just write a comment on our social media. Right now, we are finishing this broadcast and we are going offline. So thank you very much. Have a nice day. Have a nice evening in Poland, at least. And bye bye.
Bye.